Alright, so in this example we're told that the frequency of excitation for this mass spring dashpot system is changed from omega 1 to omega 2, and as a result the amplitude of the steady state response goes from x1 to x2, where x2 is 1/8 x1, and we're asked to find the damping ratio for the system. Now to help us out with this, I'm actually going to borrow a result from the notes, and in particular what the notes tells us is that the amplitude of vibration, which I'll go ahead and call capital X, for a spring mass dashpot system can be given by F0 divided by the stiffness K, divided by the square root, in this case, of 1 minus r squared quantity squared plus quantity 2 zeta r squared, where r is equal to the excitation frequency divided by the natural frequency. So if I have this result, what I can say here is that I know that x1 will simply be F0 divided by K divided by the square root of quantity 1 minus R1 squared, quantity squared, plus 2 zeta, R1 quantity squared. And I know then that x2, which will equal in this case as stated in the problem statement 1/8 of x1, is going to equal in this case F0 divided by K, divided by the square root of quantity 1 minus R1 squared squared plus quantity 2 zeta R1 quantity squared. And actually I shouldn't say R1 here, but rather R2. Now what I can do is if I want to try to find a relationship for the system, x1 and x2, is I can simply plug in now the result for x1 that I obtained before. And so what this essentially gives me is that 1/8 times x1, which is F0 over K, let me make that a little clearer, F0 over K divided by the square root of 1 minus R1 quantity squared plus 2 zeta R1 quantity squared is going to equal F0 over K divided by quantity's square root of 1 minus R2 squared squared plus quantity 2 zeta R2 all squared. Now, what can we do with this? Well, we can start by noting that F0 over K appears on both sides of the equation, so we can cancel that out. And then I can square both sides of the equation and cross multiply. So if I do that, what I'm going to end up with here is that 1 over 64 is going to equal, in this case, quantity 1 minus R1 squared. There should be a squared inside there, right, too. Sorry about that minor typo. Plus quantity 2 zeta R1 squared. That should be on the outside. Jeez, let me get that fixed up for you. There you go. Divided by quantity 1 minus R2 squared plus 2 zeta R2 quantity squared. So this is a nice result here. And basically this is a numerical problem. If you're given R1 and R2, this is a tidy thing to find, and so you can solve this numerically and simply get back the damping ratio. It's the only unknown in the system. So I'll leave that up for you to do, and I wish you the best of luck. Take care.